Hello everyone, William here. So let's talk a little bit about crop factors in cameras in relation to apparent magnification or zoom. So you could probably see that between these two images we have, let's just circle these two wind turbines here, which are these two here, and I'll prove that here in a minute or two. This is actually the same scene, but you could probably, if you're good with your eye, you could probably see the various details and confirm, at least in your own mind, that these are of the same scene, but perhaps with a slightly different framing. Uh, so, anyways, moving along. So, I think in order to cover this subject, we need to talk about lenses briefly. And by briefly, I mean to say that a lens is a lens is a lens. And what I mean by that is that just because you move a specific lens from one camera with a certain crop factor to a different camera with a different crop factor doesn't mean that you're changing the optics in the lens. That's just physically impossible. It doesn't happen. Goodbye, the end, right? Moving right along. Um, Moving right along to, I would like to talk about Nikon cameras specifically because I know Nikon cameras better than any other camera brand out there. So um, let's talk about crop factors in the FX, DX, and Nikon One camera system cameras. So believe it or not, FX cameras or full frame cameras actually do have a crop factor. The crop factor that they have is 1, right? Moving down the line to DX cameras, the crop factor with the sensors in those cameras is 1.51. The crop factor in the Nikon One camera system cameras is 2.7. So anybody telling you that a crop is a crop is a crop is full of shit. They don't know what they're talking about, right? Because, well, unless you're telling me that mathematically 1 equals 1.51 equals 2.7, well, we all should know that that's just not right. Okay? We got that out of the way? Okay, good to go. So that's just not right. Anyways, so um, the image I took here on the left again is with the Nikon D5300. The image on the right here is taken with the Nikon 1J5, and we can confirm that we are actually looking at the same rough scene here, just with slightly different framing, right? So two wind turbines, a power line tower, and a wind turbine. Two wind turbines, a power line tower, and a wind turbine, right? So a house, an outbuilding, a house, an outbuilding, a fence post, a house. And looky here, a tree and a tree. Still don't believe me? Okay, buddy, time to go fly a kite. Don't care what you do from now on out. Anyway, so the image here on the left, as the EXIF data says, is taken with a Nikon D5300. Lens was a 70 to 300 millimeter VRG at a 300 millimeter focal length. Uh, Pretty much everything is the same with the Nikon 1 J5 here. Same lens, same focal length. The only difference is the camera, right? So why did these two wind turbines look closer? Well, basically, if we use the image from the Nikon D5300 as a representation of the full scene, we were actually taking a smaller portion of the scene by comparison, right? So if we were to somehow resize this image and overlay it here to get a general idea of the representation of this image over here and check the resolution between that area and this image here, we would see that this image versus the representation of the image over here would have a higher resolution over here. And in order to achieve the same resolution in that smaller area over here, the whole camera sensor would have to have a higher megapixel or pixel density value. This camera is 24.4 megapixels. I believe we would probably have to have somewhere in order of 30 megapixel pixel density throughout this whole scene here in order to match this small portion with this here. And then we could take this image crop area and just overlay it anywhere in here and compare resolution to resolution. We'd have the same pixel density, right? So with that said, that out of the way, since we're taking a smaller portion of the scene here and we're actually at a higher resolution in this representation than over here, that is what gives us the apparent zoom or magnification. That is why when people talk about a DX sensor camera and they talk about a specific physical focal length, they multiply that value times 1.5 for DX sensors, right? Because the crop factor is 1.5 or 1.51. So the apparent focal length is actually going to be 450 millimeter. Conversely, if with the Nikon One camera system, since we have a 2.7 crop factor, we have to multiply that crop factor times the 300 millimeter physical focal length and give us an apparent focal length of 810 millimeter. So with all that in mind, that is why when you take a picture with a smaller crop sensor versus a larger crop sensor, why that smaller crop sensor appears to have better zoom or magnification on the image, because you're taking a smaller picture but adding more information into that area versus the full scene representation of that same scene. Okay. Hopefully I explained it good enough there, and if somebody else hasn't beat that horse, or if I haven't beat that horse to death already, then somebody else is going to have to do it. Have a good one.